Across the
Hello, my name is Max Briggs, and prior to becoming the program executive for NASA iTech, I managed the SBIR portfolio for the Aeronautics Research Mission Directorate, which is why I'm excited to bring you our first ever iTech event focused exclusively on aeronautics. For those not familiar with iTech, we are a commercialization-focused pitch competition searching for innovators and investors that may not consider NASA or government as their primary customer. This is a natural fit for NASA's Aeronautics Research Mission Directorate, which focuses primarily on stimulating emerging aeronautics markets and modernizing mature aeronautics markets. This gives entrepreneurs a great opportunity to engage with NASA and investors in an effort to shape the future of our airspace, and iTech is proud to facilitate those interactions. The Ignite the Night event we are bringing you today is part of a larger NASA iTech program, which aims to provide a low barrier to entry opportunity for collaboration and networking between entrepreneurs, investors, and NASA chief technologists. These events are designed to be rapid fire, allowing participants to establish many new connections outside of their usual spheres in a short time. The winner of today's events will advance as a semifinalist in the 2021 Cycle 1 Forum, which will be broadcast on May 27th, and there's still time to become involved. If you are interested in participating, please visit www.nasaitech.org, where you will see opportunities to attend or to engage as an investor, judge, or roundtable participant. During today's program, you will hear 10 3-minute quick pitches from a distinguished roster of companies, including AvaMek, Lithium FireGuard, Cityzenith, TargetArm, Moonware, Orbital Traction, RunSafe Security, Airblock Technologies, Stratadyne, and United Aircraft Technologies. After the pitches and Q&A, you will hear talks from two of NASA's innovation leaders in aerospace, Marty Waszak, who just ended his tenure as the Deputy Program Manager for AR&D's Convergent Aeronautics Solutions Program, to take a position in the office of NASA's Office of the Chief Technologist, and Parimal Kapartakar, more commonly referred to as PK, who is the Director of the NASA Aeronautics Research Institute. I'm looking forward to hearing their perspective on the state of innovation and what the future of aeronautics is likely to hold. But before we get started with today's pitches, I would like to use this opportunity to let the audience know a little bit more about NASA's evolving entrepreneurial engagement strategy, which I hope will keep NASA on the cutting edge of innovation far into the future.
Across the federal government, many organizations, including NASA, are reconsidering their role in innovation and R&D. According to the National Science Foundation, federal and private investment in R&D were nearly equal until 1987. But since then, private sector R&D has quickly outpaced federal R&D spending. This trend is accelerating and will likely continue to do so for the foreseeable future. If we look at the most recent NSF data, we see that total private sector R&D spending was almost $550 billion, of which about $140 billion came from venture capital investments. For comparison, NASA's spending on extramural R&D was about $5 billion per year. If we drill down even farther, to the NASA programs that focus on early-stage innovation, such as the SBIR program, we see that NASA is a relatively small fish in the very, very large pond of innovation. Pessimists may see this as a problem, interpreting this as a sign that NASA is being outpaced, unable to convince innovators to stop making apps and start building rockets or low-boom supersonic aircraft. But I'm an optimist, and I think this threat is really an opportunity. I think that what this data says is that NASA no longer has to go it alone when it comes to innovation, that there is a sophisticated and capable pool of innovators that NASA can now tap into to contribute to NASA's vision. To do this, we need to evolve beyond a government-only focus and figure out how to leverage the private sector effectively. Consider the historical example of NACA, the National Advisory Committee on Aeronautics. It was established in 1915 to turn crazy aeronautical ideas into usable technology. Usable at that time usually meant usable by the US government. In the early days of NACA, the cost and risk of building an aircraft and the lack of certainty in the commercial market was a large barrier for commercialization-focused companies. However, fairly rapidly, the technology progressed and passenger air travel became not only viable, but profitable. This allowed the private sector to begin driving innovation, especially innovation addressing the needs of the maturing commercial aviation sector. As this happened, NACA's role in the innovation ecosystem had to evolve, focusing less on the here and now and more on identifying and eliminating hurdles to future aeronautics markets. This ensured that America obtained and maintained a position of leadership in commercial aviation, and today, aerospace remains one of America's leading sectors for exports. For those that do not know, NACA was absorbed by NASA when it was formed in 1958, and NACA's aeronautics legacy lives on to this day through NASA's Aeronautics Research Mission Directorate, where it continues the legacy of innovating in emerging markets, including advanced air mobility, unmanned aerial systems, and low-boom supersonic aircraft. The NACA transition from innovating to serve a direct government goal to innovating to stimulate emerging markets is now providing a blueprint for how NASA can have a leadership role in emerging private space markets. Tasks that were once too risky and too expensive for anyone besides large governments can now be accomplished by private companies and sometimes at a fraction of the cost. Consider that only 10 years ago, NASA was flying shuttle missions to resupply the space station at a total program cost of about $1.6 billion per launch. Today, NASA purchases rides to the ISS from SpaceX at a cost of roughly $400 million per launch. This clearly has a direct benefit to NASA, but one could argue that the biggest impact of the new capability is making access to space more affordable for a host of commercial entities. As launch costs come down, more and more space-based business models become viable, making space an exciting host for several emerging commercial markets. If the United States wants to continue its lead in space, it is clear that we will not only need to support challenging government projects like getting astronauts back to the moon and onto Mars, we will also need to lead the commercialization of space, just as NASA has continued to innovate in aeronautics even as private sector participants gained traction. So the question for NASA is, where exactly do we fit in the framework of mature and emerging aeronautics markets? And how can we effectively engage the innovation ecosystem to maximize our impact? The aeronautics landscape is changing quickly. A commercial aviation sector that was very successful in bringing safe, reliable transportation through a system centered around airports and highly trained people is being challenged. With many commercial markets opening up that will use non-traditional aircraft in low-altitude airspace, the sheer number of aircraft in the skies is likely to prevent traditional models of piloting and air traffic management from scaling to meet the demand. While it is not the role of NASA to design drones for package delivery, it could very well be the role of NASA to de-risk technologies that make those deliveries possible, such as collision avoidance, navigation in GPS-compromised environments, hyperlocal weather measurement and forecasting, and dynamic routing. As the amount of air traffic increases, it becomes a larger and larger threat to the climate. The electrification of aircraft could provide necessary relief. You are not likely to fly across the country in a NASA-built aircraft, but you could very well fly in an electric aircraft that uses motors, or energy storage, or power management systems that were developed either by NASA engineers or with NASA dollars. And in this environment, where emerging aeronautics markets have such great commercial potential, it is important for NASA to identify places where entrepreneurs are specifically well-suited to the task and leverage their efforts to the maximum extent possible. iTech's role in this is to shine a light on companies that don't consider NASA to be their primary customer. For example, one iTech alumnus, Dimer, has partnered with Honeywell to put their ultraviolet sterilization technology onto a platform that can disinfect aircraft cabins. This type of technology could potentially help to relieve some of the burdens placed on the airline industry as a result of COVID or future contagions that threaten the industry. Entrepreneurial engagement programs like iTech are a good first step to leveraging the power of private sector innovation, providing a forum with many of the features that are expected in the entrepreneurial world, such as speed, flexibility, low barrier to entry, networking, and investor engagement. As we go forward, NASA will continue to examine its existing programs to determine how to make them more friendly for entrepreneurs and agile, growth-oriented, commercially focused companies. Where we cannot accomplish these goals with our existing programs, we will continue to innovate new programs to effectively leverage the private sector to contribute to NASA's missions and to stimulate emerging markets that are aligned with NASA's strategic goals. We hope that by keeping an eye always toward what the future of aviation can be, and by engaging with the powerful engine of innovation in the private sector, we can maintain America's place as the leader of emerging markets in both aeronautics and space.
Hopefully that video gave you a little more information about NASA's evolving perspective on our role in commercial markets and how iTech contributes to that goal, and how we aim to improve entrepreneurial engagement efforts going forward. And now I'd like to introduce you, or have the judges introduce themselves from our distinguished panel, starting with Kurt Sackstetter.
Good afternoon. I'm Kurt Sackstetter. I'm the Deputy Center Chief Technologist at the Glenn Research Center in Cleveland, Ohio.
Thank you, Kurt. Harry, could you give us an introduction?
Hello, I'm Harry Partridge. I'm the Chief Technologist at the Ames Research Center. Ames is located in Silicon Valley in California. Some of the Ames core competencies are air traffic management, aerosciences, entry systems. We both develop and test the thermal protection systems for most of the entry craft, robotics, autonomous systems, supercomputing, quantum computers, astrobiology, and life science. Some of our focus areas. Thank you.
All right. Thank you, Harry. Aaron Greenwald, could you introduce yourself?
Yeah, hi. My name is Aaron Greenwald. I'm a principal with the Boeing Corporation. I focus on corporate strategy, mergers and acquisitions, and separately, I'm also a venture capitalist with Next Gen Venture Partners in Washington, D.C., where I help focus our investments in IoT, robotics, and drone technology. Thanks very much.
Thanks, Aaron. Peter Shannon.
All right, guys, technical mute there. I'm Peter Shannon with Radius Capital. We are early stage venture investors in the enabling technologies behind advanced air mobility and deeply involved in the space.
Great. Thank you, Peter. David Voracek.
Hi, Dave Voracek. I'm the Center Chief Technologist at NASA Armstrong Flight Research Center, located out at Edwards Air Force Base. We work primary on bringing that technology to flight, getting over that valley of death from TRL levels 3 to 6. We bring in technologies, put them on airplanes, and test them out, see if they're real.
Perfect. Thank you, Dave. Julie Williams-Byrd. Julie, you may be muted.
Am I not muted? Hello, my name is Julie Williams-Byrd, and I am the Center Chief Technologist at NASA Langley Research Center in Hampton, Virginia. In NASA Langley, we are the first center. When you saw those advertisements for NASA, for NACA, that's where NASA Langley was. We have a balanced portfolio across the Aeronautics Mission Directorate, the Science Mission Directorate, and the Exploration Mission Directorate. I'm really excited to be a judge for this panel session. Thank you.
Thank you, Julie. Nancy Mendonça.
Finding all of the buttons. Hi, I'm Nancy Mendonça, and I am the Deputy for the Advanced Air Mobility Mission Integration Office at NASA headquarters. And we are working to ensure collaboration amongst our projects that are contributing to AAM and also collaboration with the community. And I also am excited to hear the presentation, so thank you.
Thank you, Nancy. Zach Ellis.
Hi, everyone. My name is Zach Ellis. I'm a CEO and Managing Director of the HTX Impact Fund, which is an early stage venture fund that's been newly created to invest in underrepresented minorities leading companies in the southeastern United States. It's headquartered in Houston, Texas. It invests in aeronautics, healthcare, life sciences, software, energy, CPG, and fintech companies. Prior to this, I spent about 10 years investing in regional venture funds, corporate venture funds, and university tech transfer offices. Before that, I was in business development and management consulting, and I started my career serving as an active duty officer in the U.S. Navy. Happy to be here.
Thanks, Zach. And finally, Mark Walker.
Hello, Mark Walker, and I'm a partner in New Magellan Ventures. It's a Washington, D.C. based advisory and venture fund. Also an investment banker with Wield & Co. in New York. My focus has historically been on the sectors of defense, aerospace, infrastructure, usually with a focus on Asia.
Thank you, Mark. And thank you to all of our judges. The interaction between the companies, the judges, and the technologists is what makes iTech what it is. So we really appreciate you all being here with us today. And without further ado, we will move on to our first quick pitch.
Have you ever wondered what happens behind the scenes at an airport? How your baggage makes its way to the plane, or why you've been sitting on the tarmac for 15 minutes, waiting to taxi and then depart? Ground handling operations constitute the lifeline of an airport, managing everything from food, fuel, cleaning, pushback, baggage, and even the transfer of passengers across an airport, enabling connections and timely operations. Airlines and airports are finding unique ways to make the passenger experience more seamless with the introduction of new technologies in terminal buildings. But ground handling and airside operations in general have not changed much in the last 50 years. Airports are becoming increasingly crowded environments, with flight volumes reaching theoretical maximums when compared to those of decades ago, while the processes required to meet this modern demand for air travel remain unchanged. Today, uncoordinated ground operations cause airlines unnecessary delays, accidents, and fuel costs, which can amount to more than $30 billion every year.
Moonware's vision is to streamline air travel operations. We're building automated ground handling processes, intelligent systems, and vehicles alike to own the back-end of ground operations at airports around the world. We're first launching a cloud-based fleet management software platform integrated with existing ground handling vehicles to automate their scheduling, dispatching, and routing. We will subsequently deploy the autonomous and electric ground vehicles needed to fundamentally reshape airport operations. Our company spun out of a collaboration with Uber Elevate to develop an autonomous pushback vehicle to ferry eVTOLs around future skyports. And until the urban air mobility market reaches the scale needed for such systems, commercial aviation can immediately benefit today from solutions like ours. Airlines are now realizing the potential operational efficiencies that Moonware's products provide.
Moonware's current path is aligned with NASA's prior work on the Aerospace Technology Demonstration 2, or ATD2 for short. We are also striving to improve the predictability and operational efficiencies of traffic around airfields through automated processes, but with the distinction that our focus is geared specifically towards the ground vehicle fleet and airports. Separately, there's an open ORWA that we'd like to respond to, encompassing several areas of interest, specifically regarding automation of ground traffic and airports and operations integration in the urban air mobility market.
Our team's experience combines decades worth of talent around Silicon Valley, hailing from Waymo, Tesla, Uber, NASA, Amazon, Mercedes, and others. We've signed several strategic LOIs with airlines and airports alike to carry out pilot deployments of our fleet management software, and are now raising capital to develop, scale, and deploy our products by Q4 of 2021. By helping airlines reduce their operating costs by more than 50%, this becomes a multi-billion-dollar market.
Moonware is building the foundations for the next generation of air travel, where multimodal transportation systems will become increasingly digitized and automated.
Join us today in our journey to disrupt the way we travel and land in the future we have all been dreaming of since our youth.
$1 billion. That's how much an average big airline has set aside for their aircraft maintenance. Out of that budget, 30 to 40% is for electrical maintenance. At the UAT, we want to cut that by 80%. My name is Eva Rising. I am the CEO of Ignite Aircraft Technologies, and we plan to do this by reimagining the way we do electrical wiring management. My co-founder Darian, a veteran who worked as an aircraft electrician for the US military for over 15 years, was motivated to reinvent metal clamps because of a career-limiting injury. Together, we lead a team of experienced engineers, business developers, and marketing professionals with backgrounds in Boeing, Lockheed Martin, the US Air Force, and Navy. At UAT, we're on a mission to replace the metal clamps used in modern aircraft that can cause or propagate electrical shorts. We want to replace them with our patented thermoplastic clamps, which are 65% lighter, are non-conductive, and are twice as fast to install, significantly saving manufacturing and maintenance costs. With our clamps, UAT can reduce over 600 pounds in large commercial aircraft and reduce the time of electrical assembly by over 80%. Earlier I said, let's reimagine electrical wire management, which is why we have embedded our clamps with a network of sensors that can map, monitor, predict, and diagnose electrical systems by measuring amperage, EMI, temperature, and other variables, all wirelessly without the need of batteries, improving fault diagnostics by over 150%, and minimizing the reliance of visual inspection and risks of human error, taking something that took days to weeks down to hours in a couple simple steps. We've already made progress in our commercialization. We've been working with the Department of Defense and secured our projects through the Future Vertical Lift Initiative and are actively working with Bell Helicopters and Lockheed Martin to get our clamps integrated into the new aircraft models. Going after a $16 billion market opportunity, our contract revenues are already over $1 million and we're on track to surpass this in 2021. In addition to recently closing a $1.5 million round of funding that we've used to test our clamps under rigorous military standards, which have passed thus far. We are currently positioned to launch our non-sensing model in late 2021 and our sensing model in 2022. At this moment, we're looking for collaborations and further opportunities to demonstrate the capabilities of our product in both aerospace and space applications. Thank you again for allowing us to show you how we plan to reduce maintenance and operational costs, and for supporting a veteran and minority-owned company as we make a difference in the aerospace industry.
Hello everyone, my name is Brian Huff and I'm the CTO and one of the co-founders of Airblock Technologies, and it's a pleasure to be speaking to you all today. At Airblock, our mission is to digitally transform the aviation and aerospace supply chains to bring the industry into the 21st century. Now, when most people think about aviation and aerospace, they of course think of the jet propulsion engines, the noise-canceling aeronautics, and the cutting-edge technology. And of course, that is the industry in the front end. But in the back end, what we have seen along the supply chain side for the last 15 years is an immense amount of paper documents, contracts, and technical records piling up for these companies. And this is something that has not changed since the Wright brothers took their historic first flight. Companies along the supply chain are still inundated with paper. And to give you some background, the fees, delays, and penalties for cargo goods and services totals more than $6 billion in revenue lost across the industry in North America, according to 2 studies by McKinsey and IATA. Additionally, for every 90 days that a plane or aircraft is grounded, the industry loses $12.7 million. Our vision at Airblock is a first-of-its-kind communicative supply chain network to fix this. From a technical perspective, what we are building is a big data, AI-powered distributed data ledger network. And what this SaaS platform would enable is helping companies digitize their documents, contracts, and technical records so they would be able to turn that data into actionable data and allow them to be more proactive as opposed to reactive. Airblock at scale would allow companies and their supply chains to be faster, more efficient, cheaper, safer, and save an estimated minimum of $200,000 to $500,000 per company per year. Right now, companies along the supply chain just don't have access to these legacy ERP systems. They're too expensive, they're inaccessible, and companies right now are just defaulting to Excel spreadsheets as data pipelines. And they're not connected, they're separate silos, and the supply chains are unable to work hand in hand together like they should. So to solve this, we've built a small but mighty team of aviation and aerospace professionals, award-winning technologists and engineers, and industry experts. And we are a woman-owned business, a multicultural and multilingual team, and we all hail from various backgrounds of leading technology, including GE Aviation, the Harvard Kennedy School, Safran, CSIRIS, and more. So far, we have received 6 letters of intent with 3 pending, and we're focused on closing our $200,000 pre-seed round and taking our beta technology to an alpha release that's ready to scale. Right now, we're really interested in strategic advisors and support from NASA. We've been primarily focused on MROs, FBOs, and OEMs, and we're greatly interested in seeing how we could partner with NASA and NASA supply chain partners to decrease turnaround times for aircrafts while increasing compliance, efficiency, safety, and speed. So if you're interested in digitizing the aviation and aerospace industry with us, we would love to welcome you aboard.
I'm Andrew Reenstrom, Managing Partner of Lithium FireGuard. Every day, cell phones, tablets, laptops, e-cigarettes, and any other number of personal electronic devices, or PEDs, go into thermal runaway in flight. A bump, drop, or bang is enough to disrupt the electrical current, causing thermal runaway. Lithium has a maximum burn temperature of 1200 degrees, and the resulting fires, explosion, and toxic smoke is enough to cause personal harm or death, especially while in flight. Lithium FireGuard is an aviation safety company. Its PG100 is a patented solution focused on the containment of fire, explosions, and toxic smoke due to thermal runaway of PEDs, all while protecting the firefighter through a clear poly screen. Once the device is contained within the PG100, its secure latches hold the burning PED inside while the noxious fumes are vented safely through two-stage particulate filters, all while relieving pressure from within the unit. Although never required, an airtight water gasket is available to quickly extinguish the fire and drop the core temperature of the runaway lithium. Various burn bags are a cheaper alternative to our solid PG100 box. They do not fully contain the fumes or flames, and the FAA specifically advises against the use of burn bags. Lithium FireGuard is the exclusive licensee of the intellectual property owned by George Brillmeyer and Highwater Innovations. The PG-100 had gross revenues of $370,000 in 2019, and in 2020 had gross revenues of $170,000. We also believe other verticals exist outside of aviation. The PG-100 has a client base of over 175 different users, included but not limited to Air Force One, regional airlines, cargo providers, U.S. and other international military branches. NASA has currently purchased 4 units beginning in 2016. Our NASA iTech goals include first protecting the entire Earthbound NASA fleet and working in conjunction with NASA to adapt the PG-100 for space travel. We have a strong team in place who have experience bringing other products to a mass audience. Thank you for your time. I'm happy to answer any questions you might have.
The problems related to most conventional helicopters include the piston engine, belts and gears, main and tail blades, transmission mechanism, and flammable fuel. These items are responsible for 70% of major failures, according to Global Safety Board records. AvaMek helicopters are simpler, safer, and cleaner. Our CEO is Ricardo Cavalcanti, who has a background of 26 years in aeronautics. Based in Hawaii, the AvaMek team knows the importance of a quality management system approved by the FAA. Our helicopters are built to military specifications and with quality assurance. Our goal is to support the military, government and state agencies, and also private users. We offer a one-seat copter weighing 220 pounds and a full carbon fiber two-seater weighing 350 pounds. These rocket-powered helicopters with unique features are able to take off in 14 seconds with no costly mandatory engine overhaul, no transmission belts, gearbox, pedals, and with non-flammable fuel. They use hydrogen peroxide and a catalyst, combining a renewable energy source that emits water vapor and oxygen in a very silent flight at 72 decibels. The rockets that we have developed are just 9 inches in size, weigh just 1.8 pounds each, and 2 of them on a helicopter create twice the power of a traditional two-seater helicopter engine. Our drone can lift 800 pounds, which is ideal for search and rescue and special missions. Our helicopters stand above all others and have been supported by the U.S. Air Force and DoD agencies, as well as expert personnel in the field. American allies such as the UK Minister of Defense, the Brazilian government, and France have also shown high interest in this disruptive technology. We received a letter of approval from AFWERK SBIR USAF, and we look forward to working together with contributions in the search for aeronautics solutions. We received a letter of support from the USAF AFWIC Deputy Team Lead in Disruptive Technologies, stating, "I can attest to the potential this solution has in meeting critical technical needs within our mission area." We are preparing a Series A funding round and successfully conducted 300 hours of prototype test flights, and all 3 models have been tested and approved for quality and superior performance, and is at NASA TRL-8. AvaMek is ready to begin production and is working on a silent 6-seat craft currently on the design board. Thank you.
The world's 10,000 cities are complex, inefficient, and growing faster than ever. And we now know that we must build the equivalent of 10,000 more cities in the next 30 years to accommodate surging urban populations everywhere. But how? This huge volume of construction translates into over 1 million megaprojects, but current design, building, and operational software was created for single buildings, not cities. That's why I founded Cityzenith. I'm the CEO, Michael Jansen. As an architect originally, I worked on mega projects globally for 25 years and witnessed firsthand how this data cap causes over 90% of the world's largest projects to run over budget, wasting $2 trillion globally in the global economy. The major root cause is that existing software tools in our industry do not play nicely together. Smart World OS, our groundbreaking digital twin platform, was created to fix that problem. Digital twins are virtual replicas of real things connected to tons of data and powered by analytics, and they can show us how to better plan, build, and run our cities. Think of our smart world as like SimCity, but for real cities using real data from real sources to solve real problems. Originally developed by the creators of Google Earth, Smart World aggregates more data and software than any other in the industry, enabling our small company to take on very big building projects anywhere in the world, be they infrastructure, real estate, or energy sector, and even in the airspace above cities. The digital twin market is booming, worth $4 billion in 2020 and expected to grow to $48.2 billion by 2025. Forbes reported that the next 5 years will see 500 major world cities rely on digital twins operationally. We aim to be the platform that those 500 cities rely on. We have already signed $4.5 million worth of commercial contracts this year, including with the U.S. military. And Cityzenith had 1,000 media mentions in 2020, including in Forbes, the BBC, and in TechCrunch. Here's a look at one of those commercial projects, a city-scale digital twin for the Orlando Sports and Entertainment District, integrating hundreds of urban data sets with building and sidewalk-mounted IoT sensors that monitor a multitude of functions, including pedestrian flow, vehicle traffic, and even the microclimates between buildings. This twin will focus on allowing users to optimize energy consumption and visualize key results for the many stakeholders. City-scale digital twins are exactly what's needed to enable advanced air mobility in American cities. And we believe that the lessons we have learned managing such complexity at street level can be neatly transitioned to the air above cities as well. Last February, Cityzenith met with NASA engineers to discuss how digital twins could allow air traffic controllers to simulate drone routes and model weather conditions in the airspace above cities, especially between high buildings where microbursts can threaten drones and air taxis. So if asked to collaborate with NASA, we are confident we can work together to develop a flexible version of Smart World to enable air city travel in America. Thank you.
Greetings to NASA, the panel of judges of NASA's iTech's Ignite the Night AERONAUTICS event, and all of today's audience members. I am Alex O'Shea, a member of RunSafe's marketing team. RunSafe Security was founded on a fundamental question the Department of Defense asked us. If you assume the software supply chain has been compromised, how do you still deliver secure software despite the compromised supply chain? Here is Joe Saunders, founder and CEO of RunSafe Security, explaining our approach.
Our world-class security research team, consisting of former U.S. government cyber offensive and defensive specialists, started with the great promise of software. Each instance of a given software is identical to every other instance. This means with the same inputs, we should always expect the same outputs. The problem is this determinism and predictability also serves the attacker. If a nation state finds a vulnerability in one drone in a fleet, it can compromise any drone in that same fleet. And as a result, it could then steer a drone off its course, hold it for ransom, or even crash it. In short, a single vulnerability can threaten not just system resilience, but mission success of any of the drones. What our team figured out is an automated way to make every instance of the software remain functionally identical, but in fact be logically unique, so that an exploit built in the lab cannot affect the device in the field or the drone flying over the sky.
Now, you're probably wondering how this technology works, what makes it unique, and what gaps other solutions are not resolving. Again, Joe Saunders to explain.
Traditional scanning tools and patching methods catch only 50% of the weaknesses in code that attackers can exploit. And as we've seen from SolarWinds, we inherit vulnerabilities from our software supply chain. At RunSafe, we've taken a unique approach to protect your systems through our multi-patented cyber hardening product called Alchemist. With Alchemist, we make each instance of your software functionally identical but logically unique by randomizing where functions load into memory. This robs the attacker from the determinism to build a reliable exploit and protects you from both known and unknown vulnerabilities.
This technology is not just research code. RunSafe has gotten substantial market traction across critical infrastructure, enterprise IT systems, and cloud deployments.
We have secured software for the U.S. Air Force, its Platform One program, Space Force, U.S. Navy, Department of Energy, Lockheed Martin, Bosch, GE Aviation, and many other companies. And we have a $10 billion addressable market ahead of us. Alchemist deploys in minutes, fits easily in your software pipelines, and is approved for programs that offer continuous authority to operate for the Department of Defense. We closed our $10 million Series A funding in January of 2020, including $2 million from Lockheed Martin, and are looking to integrate our software into NASA's DevSecOps program to protect mission systems. Thank you, and we appreciate the opportunity to participate today.
My name is Ed. I am the CEO of Stratadyne.
My name is Nick Communion, and I am a co-founder at Stratadyne. I work on the hardware and technical development, and as such, I am the Chief Technical Officer.
Hi, I'm Bryce, and I am the co-founder and COO of Stratadyne.
Hi, I'm Victoria. I'm a co-founder and head of marketing at Stratadyne.
It's an incredible time for aerial data. Our troops use it to plan missions, and our farmers use it to spot disease, and everything in between.
But there's a big problem. Aircraft require pilots and maintenance, while drones require a team to go from location to location, resulting in hundreds of thousands of dollars in frequent aerial imaging.
Existing platforms can only fly for a few hours at max, which leaves imagery from being able to constantly be updated, and that will leave users from having crucial information to make decisions.
We fix this by using balloons to stay over a targeted area, so users can spot problems instantly instead of having to wait for the next imaging flight.
By flying into the stratosphere and above, we bypass all commercial airspace regulations from the FAA, and we can fully automate our balloons, so just a small team needs to service it without requiring more pilots. One platform itself can cover over 180 square miles.
And whereas existing solutions can only fly for a few hours, we can stay over a targeted location for months at a time using patent-pending control systems.
We combine the coverage of satellites with the high resolution of aircraft with an imaging rate 100 times faster at 1/10 of the cost.
Since each balloon covers so much land, we can monitor for hundreds of users every minute.
After capturing images, we process them on the edge to provide almost instantaneous detection of objects and potential threats. Our solution doesn't just enable you to see areas in real time, but also lets you create more detailed datasets from past images for more accurate modeling. In fact, we've been able to help our users achieve over 95% accuracy in object detection of vehicles and buildings. This insight supports us in identifying local boundaries and landmarks, modeling terrain changes, and tracking objects over long distances. I've known our team members since college, and I've been working together with them for years. Our diverse expertise gives us a strong understanding of what we're building and what our users value. We're already evaluating our technology through a grant with the National Geospatial Agency. And we're also working with Esri, the world's biggest provider of GIS software, to provide imagery datasets over remote areas. We've also completed a pilot with several commercial users in our initial agricultural market that saved them over $40 an acre and reduced resource uses by over 37%. And we're allowing follow-up on this with 15 commercial users going live for a pilot spanning over 10,000 acres and 30 more booked for 150,000 in traction. We look forward to the day where we can monitor and model the planet with unprecedented accuracy. Thank you for your time, and I hope you join us on this journey.
Orbital Traction's business is making rotating systems more efficient. Our technology optimizes the performance of engine and electric motor-driven systems, providing an affordable and cost-effective solution and dramatically reducing energy cost and the associated carbon footprint by up to 50%. Hi, I'm Stuart Schaff, the president and founder of Orbital Traction, and today I would like to share with you our technology and how our solutions can help NASA improve the performance and optimization of manned and unmanned aerial systems. As unmanned aerial systems continue to grow in popularity with both commercial and military consumers, there are multiple demands for system improvements, including increased operating range and electrical power, improved reliability and fuel efficiency, and reduced carbon emissions. Battery-operated aerial systems are currently limited due to battery size, weight, and energy storage capability. Orbital's Compact Advanced Hybrid Power System, or CAPS system, provides a fuel-electric hybrid driveline solution. The CAPS system reduces volume and weight of the driveline by more than 50% and increases system efficiency by 30 to 50%. Our technology will significantly extend the range and mission capability of existing and future aerial systems. The CAPS system independently couples a high-performance generator and an advanced rotary engine to the prop using a mechanical adjustable speed drive, allowing each element to independently operate at its optimal speed. The system compounds power from the separate components, providing an overall improvement in power throughput and system-level efficiency. The novel adjustable speed drive behaves like a continuously variable transmission and is based on a ball bearing concept that is simple, modular, and low cost. The engine and generators produced by Freedom Motors and LaunchPoint Technologies have both been developed under prior NASA SBIRs. Orbital has successfully completed multiple SBIRs for the DoD for various ground systems. With more than 50 patents worldwide, Orbital is in a strong position to confidently enter a variety of markets. The UAV market is predicted to exceed $75 billion by 2027. Orbital has a very experienced team, and we plan on entering the market through strategic partnerships. Orbital is located in Houston, Texas. In the past 5 years, we've generated $7 million in revenue, and we're currently raising our seed stage funding. This is my fourth startup, having exited the first 3 with significant returns to investors. Orbital's modular solution is not limited to drivelines. We have an active customer development effort in industrial applications, advanced power generation, and energy conversion. The expanded market exceeds $300 billion per year. Our ongoing R&D and commercial efforts benefit NASA taxonomy in 3 technology-focused areas, including propulsion systems, aerospace power and energy conversion, and mobility systems. We are excited to participate in Ignite the Night and the opportunity of working with NASA to create systems that achieve our mutual goals of making our home a greener planet and reaching for the Moon, Mars, and beyond.
People across the world are in transit more and more every year. In addition, digital networks now connect people in all modes of transportation. But why can't our physical world connect to us as well? With the massive proliferation of autonomous drones, why can't we have things delivered to us while we're going somewhere? Those are good questions. I'm Jeff McChesney, CEO and founder of TargetArm, and I can answer them. We can. For aerial drones, the big problem is about the last inches of delivery. It's really difficult to land on something moving until now. This is Tular. Our simple but elegant device launches and recovers both rotary and fixed-wing drones autonomously from any moving vehicle, train, bus, ship, or even an airplane. Imagine the possibilities, from package delivery to oil and gas, to first responders, to the military, and even to airplanes. Here you can see a fully automatic Tular recovering a drone and how the pin array actually works. And here you can see a fully autonomous drone and fully automatic Tular working in perfect unison for a hands-free recovery. Also, please note how Tular automatically launches a fully autonomous drone and how its station keeps with Tular prior to exiting on a mission. We have a very large addressable market, as shown here with just 2 of our use cases, just in the United States. We currently have limited competition, with virtually all of the money going down to the bottom left corner, with launching drones from static locations and only dealing with one type of drone each time. To make Tular happen, we have an exceptional team, possessing the key capabilities of aeronautical engineering, mechanical engineering, electrical engineering, and computer science, also while steeped with sales and entrepreneurship. Our strategic timeline is aligned perfectly with the market, starting with the military, following with oil and gas, and wind farms this year, and then package delivery as the national airspace opens up. We've gained significant traction with SBIR and STTR contracts for the DoD, as well as a contract with BAE Systems. Most importantly is our recent R&D contract for putting Tular on Air Force mobility aircraft, and in this example, the C-5 for persistent air dominance. So I need your help. I'm asking NASA for help with the complex aerodynamics and access to wind tunnels to accelerate development. I'm actively seeking funding from angels and VCs for our C2 round. And thank you very much for your time today.
All right, we're going to go into the Q&A portion. Robin, I will let you call up the list in order.
All right, great. Let's start with you, Harry, please.
Wow, that was very nice. All 10 presentations were excellent. My first question is for RunSafe. I have 2 questions for you. What is the impact on the execution speed?
Thank you for the question. There's less than 1% impact to overhead. Our engineers like to say infinitesimal and close to 0 impact to performance overhead. There is a very small impact at load time, around just 1 or 2 percentage points, but in terms of overall system performance, less than 1%.
And then can you describe your income model? Do you sell the software, lease it?
We license our software on a subscription basis that allows you to incorporate it into your software build processes and use that on an ongoing basis.
So is it as much software as you compile, or is it by person, or is it for each, is it metered by how much you use it?
Yeah, it's metered either by the number of code bases you're applying it to, or the number of devices that would be ultimately protected in the field. So, but with that in mind, you can use it and reuse it as much as your code changes. You can use that as part of your build process repeatedly.
Okay, my next question is for United Aircraft. Your smart clamp, can you describe what defects it can detect? For instance, does it work on the conduit, the insulation, the conductor? So if you bend the wires a lot, the conductor can fail?
Certainly, yes, to answer your question, it does work on all those different scenarios. It monitors the way the amperage is flowing, and then it corroborates it along with the other different sensors in our system to make sure the diagnostics or the diagnosis is given is accurate. It doesn't matter how much amperage is going through, how little is going through, if it's parallel or going in opposite directions, we're able to, with our algorithms, we're able to tell the difference.
So is it a electrical connection, or is it a remote detection?
It is a remote detection. It's an in situ clamp that can able to monitor and do remote detection and monitoring of the full electrical system.
Well, thank you very much. TargetArm. Do packages need to be rigidly attached or inside the UAV?
Is this for TargetArm?
TargetArm, yes.
As of right now, we don't have a specific parameter for that. Right now, they hang below the drone.
And you can still capture the UAV even if it's hanging below.
Correct. The pins they conform to whatever shape goes in there. So if there's a package below it, they just conform around that package.
But if it's hanging down below, it's not a problem for you in that you don't actually capture it?
Oh, you mean hanging down on a string?
Yeah.
So it would need to
It has to
be
be rigidly attached. Rigidly.
rigidly attached below the drone. Yes. Sorry, I misunderstood the question.
Okay. And how fast can your vehicle be moving when you capture a UAV? And is that a relative velocity?
We try and co-speed as much as possible. The difference in speed that we've done right now is around 5 miles per hour. The max speed that we've done a recovery is about 35 miles per hour, and the max launch we've done is just over 65.
Okay, thank you very much. Stratadyne, can you say something about how high you go? Actually, I know you're in the stratosphere, but how high in the stratosphere?
80,000 feet.
Okay, and who is your competition in this?
In the stratosphere, you mean?
Yes, for balloons.
Urban Sky, Worldview, and Near Space Labs. However, Urban Sky and Worldview are going after different use case, and they use latex balloons that can only fly for a few hours compared to ours that fly for months.
Okay, and how localized, how much can you control where its range and motion?
Right.
I know you assume you're going up and down like Loon, but
Yes, in fact, we are going using the control system similar to Loon, and right now we've been able to keep our balloons within the 2-mile radius of any given point.
Very nice, thank you. Orbital Traction, can you say something about the range improvement? Give an example about how far you can go?
Yes, so the range improvement has to do with the fuel efficiency, and we can save approximately 50% of the energy through the system. So almost twice the range.
Okay, thank you. Cityzenith, what sensors do you interact with? Are they proprietary, or can you interact with whatever sensors are in the building?
Cityzenith, you may be muted.
Sorry.
We can integrate IoT sensors of any kind from any manufacturer. We use various standards for that, including the Haystack standard for IoT sensors for building sensors in America. And that aside, we can integrate with any independent vendor through their API.
Okay, thank you very much. Orbital Traction, can you quantify the range improvement? I'm sorry, I just asked you that one. AvaMek, I hope I'm pronouncing that right. What happens if one of your propulsion units fails? Can you operate or land on one propulsion unit?
Well, we have an excellent auto rotation. Okay, we using that system, we can improve the auto rotation about 400% of the cone of the potential place to land. But even if they fail one rocket, the other one is able to completely perform the fly, because each rocket they have like 102 horsepower. So a unit that the DF1 have 202 pounds empty weight, so we fly them at the rate of 20 to 1 because we have 204 horsepower and 2 rockets.
Very nice. Can you tell us what concentration of hydrogen peroxide you use?
We use above 70. The ideal is 82.
Okay, and you don't have any trouble with distribution of 82%?
No, we do have a type of control for handling, okay, training that is given for the company that delivered the hydrogen peroxide, but so far I have no trouble to buy hydrogen at 80, 85%. That's completely available everywhere.
All right, thank you, Harry.
Okay,
we'll come back to you. I know, we'll come back to you. Mark Walker, if you can ask your first question, please.
All right, thank you. Maybe I can pass some time back. So I guess my first question is for Cityzenith. In your pitch, you talked about the market for digital twins growing to about 50 billion by 2025. There's already quite a few well-established, well-funded multinationals in that market. So what is the differentiation between your offering and them? I'm just trying to understand your ability to scale growth.
Our company took a platform approach. A lot of the existing players, Autodesk, Bentley, Esri, were actually repurposing existing GIS, BIM, or other tools. And the platform approach requires some fundamentally different architecture, game-based engines integrating with data science and a Kubernetes backend. So it's a whole different approach that allows us to scale this. Those technologies just simply don't do it beyond the scale of an individual building. And as we saw project sizes getting larger and larger, there was just no product that served that market.
Great, thank you very much. My next question is for Moonware. So in your video, we saw the relatively cool-looking autonomous pushback vehicle, and that seems to be your near-term revenue focus. I guess what I wanted to talk a little bit about was your long-term revenue focus, how you grow into a larger competitor with somebody like Swissport, and over time ramp up your revenue.
That's a great question. So the software component is what is laying the initial groundwork for the autonomous ground handling ecosystem, which is vehicle agnostic, so it can integrate with all sorts of ground support equipment across the airport. And in the long run, as we start integrating hardware systems, such as the autonomous pushback vehicle and other vehicles, that's how we're completing basically that integration, which is that of hardware and software.
Excellent, thank you. So my third question for Stratadyne, I'm not quite sure if I understand what exactly your product or service is. So are you selling some sort of a pre-processed remote sensing geospatial data? So your competitors are somebody like Digital Globe or Maxar, or are you selling the platform, buy a balloon and all the sensor equipment that goes with it and they can do with it what they wish? Or are you working with existing providers, somebody that maybe already running LiDAR runs and giving them your platform to utilize? I guess, what is it that you envision and how does that grow over time?
Gotcha. So right now we are selling data. We sell data to Nano subscription, monitoring subscription, and to data marketplaces like Up42 and L3 here as Steelspace.
So is it on a per contract basis? So a client says, we want you to provide data for this specific geographical area, or I guess, how do you charge?
It's on $4 per acre. So essentially, if a client says they need us to monitor an area of 2,000 acres, then we go ahead and monitor it.
And how many platforms do you currently have that you're operating? 2. Great, thank you very much. Final question for United Aircraft Technologies. So I understand that next year you're going to be launching your sensor clamp. So IoT devices generally have to undergo some fairly rigorous testing for both the network, but also for security. What are the regulatory hoops you have to jump through before you can take it to market?
Excellent question. So far we've tested our base model clamp, which is the body for our sensing clamp under military standards for clamp and fastener device, and it has passed thus far. The next steps that we're going to do is for the electronics compartment for water submersion and resistance to phosphate and S's found in hydraulic fluids. And these are set to be tested around October of this year, giving us enough runway for a couple months if anything needs to be reworked on. We work currently with the Air Force Research Lab in Rome, New York for the cybersecurity and network part. We work with AvaMek, one of the leading companies for this, to make sure we're moving ahead in the certification process.
Excellent. And thank you to everybody for excellent presentations today.
All right. Thank you so much, Mark. Next, Julie.
Yes, good afternoon. First of all, I wanted to thank all of the presenters. The work that you're doing is extremely innovative, and there's a need for it. So it's one thing about being innovative, but also you've identified some real good challenges. My first question is to United Aircraft Technologies and the sensor system and the thoughts about minimizing visual inspection. And so my question is, the data that comes from the sensors, do you continually monitor that, or do you see a problem and then you provide the data to the people who need to see it, or is it stored, or how does that data from the sensors work?
Excellent question. So the first stage is the data that comes in when they do need to make this inspection, when the pre-flight, post-flight will tell you there's a problem rising so you can address it quickly. The data that accumulates historically, it is used for all algorithms to be able to do predictive maintenance on our electrical systems. We follow the MOSA initiative, making sure we're integrated with any other programs that are out there. And as we continue to gather both historical real-time data, we're able to better train our algorithms to be able to do predictive maintenance and therefore continue to reduce the operational costs and aircraft downtime down the future.
Thank you very much. My next question is for Airblock Technologies. And I think it's timely to be talking about supply chains, especially with the issues that we're having in the Suez Canal right now. So I think, timing is everything, right? So as far as, the supply chain issues, and I realize that you're focusing on, the paper products and digitizing those paper products, and that's one good thing, right? But the other is to come up with solutions when that supply chain is not available. So how are you connecting to alternate supply chain opportunities as opposed to, just coming up with a solution to that one supply chain issue? Does that make sense?
Absolutely, and that's a great question. I'd say in terms of our technology stack, one of the key aspects of the Airblock platform is data extraction. It's an AI tool, but it can extract data from documents. So what you'd be able to do is simply drag and drop a document. It can parse and extract the data, and then you'd be able to run basically a series of functions to create actions, predictions, notifications, and connect supply chain companies together. Oftentimes in the industry, you can sort of digitize your space, but not the spaces of others. So that's really where the Airblock network at scale would be very valuable, because companies would be able to communicate together. They could anticipate problems. You'd be able to see down the road if there's blocks, if there's problems, if there's issues. So we really want to make this not just document storage, but really predictive. supply chain as well.
All right, thank you very much. My next question is for Lithium FireGuard and the FireGuard system that you have. I know that's something that is sort of known about the lithium batteries and the fires. Is there a lot of opportunity to, is there a real business in that particular area where there are fires on airplanes and you can use your equipment? That's the first question. And then the second question is, as NASA goes to space and we have these vehicles and systems that are far, far away, do you anticipate perhaps the same fire protection type of devices available for human exploration?
Yes, thank you for the questions. Both very good questions. Yes, there surely is a need right now. Lithium FireGuard is a current product in production being used by the airlines, corporate aviation, cargo aviation, but also there's also needs for hospitals, laboratories where they test batteries, dormitories, hospitals. So yes, for sure, there is it's a growing concern is the lithium ion battery and the prevalence of the lithium ion battery. And naturally, our thought process as far as NASA is the future needs, for lack of a better word, and how this type of solution can be used outside of current uses. Obviously in space, is it other craft that go into outer space or lunar craft in laboratories, space labs. So for sure, those are the types of items that we're thinking of that will be needed in the future.
Okay, thank you. And my last question is for RunSafe Security and the cybersecurity software. We all are dealing with cybersecurity and attacks on our software, and it feels like we can never get ahead of the attacks. How would your business help us to either predict attacks or guard against attacks and be on the offensive as opposed to being on the defensive and cleaning up things after the attacks?
It's exactly why we started RunSafe Security. We protect against both known and unknown vulnerabilities by the approach that we take. So we randomize where functions get loaded, which means if an adversary or a nation state or an attacker knows where a weakness is that the rest of us haven't yet figured out, because we relocate where those functions go in memory, the attack fails. And so in that regard, it helps both anticipate or block unknown vulnerability or attacks against unknown vulnerabilities, but also smooths out patching challenges that can slow down operations and cost a lot of money.
All right, thank you very much. That's my last question. And again, thank you everyone for your presentations. Great ideas, great challenges you're addressing.
Thank you so much, Julie. Kurt Sackstetter, you're next.
Very good. Thank you, Robin. Good afternoon, everyone. I'd like to echo what Julie said. This was a terrific group of presentations. I learned a lot, and the wheels are turning, so thank you. My first question is for Airblock. This is quite a challenge that you're undertaking, replacing paperwork-based stuff. So is there a precedent? Have you achieved something similar to this that you're applying to this undertaking? And I guess very closely related to that, what do you see are the challenges to getting a large organization to actually convert from a paperwork scheme to how you're doing it? You've clearly thought about that, but I'm interested what your approach might be.
Thank you for that question. Definitely top of mind for us at Airblock. I'd say we're sort of working in tandem to the paper-based documentation processes. It's sort of, we consider it to be an evolution of document management. So while you have the paper, documents that you need to store, we're then going to be able to help you digitize this whole process. So there'd be a whole other series of networks where you'd be able to then create actions, notifications, and then really be able to run predictive supply chain. So I see us sort of working hand in hand with paper, but once kind of like you have your paper-based notes, if you put that onto the computer, you can now send that to someone. You can now search for it. You could create calendar actions and notifications. So it's really that next series of supply chain where I see us sort of being disruptive and how the processes are currently running in the industry.
Okay, thank you. My next question is for Stratadyne. I understood, the balloon in the stratosphere, but there's a lot of wind at those elevations. What do you have any methodology for station keeping so that you are oriented with what you're observing?
So at 80,000 feet, there is very little air pressure, so the wind there, though strong, it doesn't have much of an effect. We do use the Google Loon system for station keeping, in which we drop altitude, and since wind moves at different directions at different altitudes, this has enabled us to stay within a 2-mile radius of any given point on the ground.
Okay, very interesting. Thank you. Next question is for Orbital Traction. I guess I'd like you to say a little bit more about how you power the devices and the energy savings. It went by pretty fast. If you could just go over that again a little bit.
Yeah, absolutely. So people are fully aware of rotary engines for using standard fuels and the move to electrification. The hybrid solution actually utilizes a technology that compounds the two, both an electric solution and a fuel-based rotary engine, and allows us to couple both of the technologies together. So you would end up with batteries and fuel, but the amount of each is reduced. And when you look at a standard fuel engine, the issue is the size of it is designed for climb and decline and moving in elevations. When you can couple the two together and utilize it in a compounding method, you actually reduce the overall size of the units by up to, it's more than 50%. So volume decreases by about 50%, but total mass and weight decreases by almost a factor of 9.
So to follow up, the fuel, you're talking about a combustion type system or versus a fuel cell? That's what
Correct.
I was trying to understand a little bit better.
Yeah, and that's actually a good point. Whether it's a fuel cell or a combustion engine, it doesn't matter to us. Our first units, the hybrids, are based on a fuel combustion engine.
Okay, all right, thank you. I understand much better, thanks. I think what would be my last question is for TargetArm. You talked about, you want to do testing coming from a center that does a lot of wind tunnel type testing, et cetera. I'm interested in what sort of testing requirements you have that could be accomplished in a wind tunnel.
Yeah, so we don't have the capability to do anything over basically ground-based speeds, so car-based speeds. So the next thing, our founder comes from an Air Force background. He was an F-15 pilot, and he really developed this as part of something that can go on an aircraft. So we want to get to that stage, and we need to be able to test our technologies at aircraft speeds.
Okay, and when you say aircraft speeds, you mean low altitude, hundreds of miles an hour at most, not high performance aircraft, anything like that. So this is okay.
200 to 300 knots, most likely.
Okay, all right, thank you. And so the idea is you need a wind tunnel that's big enough to actually actuate all of this stuff inside a wind tunnel, which is a little bit unusual for wind tunnel operations. Okay, yes, thank you very much. Very interesting. And Robin, that's all I had today. Thank you.
Great, thank you so much, Kurt. Zach, do you have any questions?
I do. Trying to get my machine to work. Hi, yeah. So my great presentations, everyone. My first question is for Moonware. I'm gonna try to take these in order. And maybe I missed this, but can you talk about your current traction and funding?
Absolutely. So we've been bootstrapping everything till now. Some of our traction in industry includes with airlines and airports, both in Europe and the US. We have obviously NDAs in place, so I can't really disclose who those are at the moment. But this is specifically regarding conducting a pilot deployment of our software platform at these specific airports with airline partners.
Okay. And then what type of IP do you have around some of your systems?
Great question. So our vehicle right now is currently patent pending. And this is regarding the autonomous pushback vehicle. And this specific vehicle was designed for urban air mobility and general aviation / business aviation, but we're currently working to scale this up for commercial narrow body airliners.
Okay. And then how does your software account for some of the biggest sources of inefficiency and error at airports, which is humans?
Great question. So what we've realized is that there's a huge lack of coordination between all the ramp agents that work on the ground. The way that's done today is basically entirely walkie-talkie or radio based, where dispatch teams through a crew chief essentially coordinate teams. But of course, because flights are dynamic and schedules are always subject to change, and rearranging teams is a very manual process, especially dispatching and the routing of the vehicles, we realize that having everything on a centralized platform has huge benefits, especially to minimize time and minimize turnaround of aircraft.
Okay. Thank you. Next, questions for United Aircraft Technologies. Can you talk a little bit about what your clamp is made of? I don't think I caught that.
Sure. Our clamp is made of thermoplastics, which is PEEK, which is a glass reinforced. And the key thing here is our cushion, which I'm not allowed to say in a public forum, but our cushion actually simplifies the clamping system, taking the 7 to 8 clamps with different color coordinations down to 1 or 2 clamps, which is how we help with the supply chain.
Okay. And are your clamps patented? Do they have either design or material composition patents?
I'm glad you asked me this because I'm very excited about that. We are patented and we just got issued our second patent. We have a PCT protected internationally, and we filed on Canada, Brazil, Europe, and Arab Emirates. Oh my gosh, Spanish is coming through.
Okay. And then can you talk about what your weight savings was based off of? I think you mentioned 600 pounds in aircraft, something like that.
Yes. Certainly, on a commercial aircraft, you have a lot of these clamps around. There's easily 20,000 of them in one. And these clamps use screw nuts, washers, all of that hardware associated with it. And when you have them in a large amount of number, the weight quickly adds up. Our clamp, because we simplify that process, we're 65% lighter. And by being 65% lighter, we're able to reduce that a large amount of weight. On a rotorcraft, for example, that will be around 60 to 80 pounds. And so the bigger the aircraft, the more weight we can save.
Okay, and you could replace all of those clamps and bolts and whatnot on a commercial aircraft. You mean like a commercial passenger aircraft?
Yes, our clamps are built so they're easily retrofitted. And even though we're moving towards our carbon fiber frames, which are a little bit more different, we also can integrate with carbon fiber frames, which is essentially very important as we look into electrifying everything as we continue to go towards the eVTOLs.
Okay, last question then. What's the current status of development for your sensing technology?
Excellent. So we have all of our sensors are integrated with our energy harvester. We've tested it in live wires. We worked on flying it on our drones and UAVs. So currently we are at the stage of a TR level 5 and 6. By October, we're hoping to reach the TR level 7 to 8, and then finally be ready for launch in 2022.
Okay, thank you. Next question is for AvaMek. I'm saying that right? AvaMek?
Yes, you said it right. It's AvaMek.
I just want to clarify, is your primary commercialization focus on producing the rockets or the helicopters as a unit with the rockets?
The helicopter itself, everything.
Okay. All right. Thank you. That was it. Then next, TargetArm. Can you talk about the retrofitting cost to install one of your landing systems into an 18-wheeler or whatever platform? Kind of now versus in the future, what you envision it being?
Yep. So we built it as a bolt-on system. So it has its own internal power system. You just need to hook it up basically as an IoT device and bolt onto the frame of whatever you want to put it in, whether that be a tank, a personnel carrier, or a large package delivery truck, which is what we have it in now. The cost of it is, we estimate, depending on the size of the unit what you want to put in, is anywhere between $10,000 and $50,000.
Okay, and so the one that you showed where it rose up out of the truck, that was like a specialized thing that you did that wasn't the typical installation you envision?
No, that was a typical installation. That was the one you saw in the video. Well, there was two in the video. One was a larger unit that we have for a little bit larger drones. One was a smaller 2x2 foot unit that was in one of our, it was actually a USPS delivery truck.
Okay. And I do have one more for Traction LP. Can you speak to the battery storage and charging needs needed to support a UAS drone?
Zach, could you be a little bit more explicit in terms of what you're asking?
Like how much storage, how much battery storage capability do you need to complement the fuel side of your engine, and then where does that, I'm trying to understand the infrastructure needs to install the system that would charge such a battery.
Yeah, so ultimately it comes down to the actual size of the system that, or the UAS that you're moving. Most of these mid-sized vehicles, the idea is that because the lithium batteries tend to be large and don't have a lot of energy storage, the actual energy density in the fuel itself is much broader, and you use the feedback from the prop when you're changing altitudes. If you're dropping, you can use the prop to charge the battery, or you can use the engine to charge the battery. So if you think about it as an energy compounding device, you can actually charge the batteries through multiple ways. So you don't have the issues with that you have with the battery going dead or having limited flight.
Okay, thank you. That's all.
All right. Thank you, Zach. Appreciate it. Dave Voracek, you're next.
I think I'm live. So yeah, a lot of great presentations and great write-ups and everything. And so I'm as excited as the other. So I'm going to try to get through some of my questions here. For Moonware, Zach asked a question, but I'm going to follow up on it. So in the thoughts on managing the non-autonomous vehicles and the people, can you talk about your biggest challenges in that area?
Yeah.
How to coordinate that?
Happy to elaborate. So the first focus that we have currently is the ground support equipment fleet management software. There's three primary users, right? So the first user would be the ramp manager, or the person who monitors all the ground operations of an airline. Second user would be a ground vehicle driver or ramp agent. And then lastly, there's a monitoring tool for the pilots in the cockpit as well. And so the idea is that by having all these agents on the same platform, it's able to see all the real-time status updates of where ground support equipment are, such as whether they're en route to service aircraft, whether they've been dispatched, or whether that's pending. And then lastly, as we start incorporating, let's say, hardware systems, autonomous hardware systems, such as a pushback vehicle, that will be replacing, the current tugs of today, for instance, where you require, let's say, 3 to 4 people on the ground. So currently, you require anywhere between 15 to 25 people to turn around an aircraft. Eventually, down the line, our vision is to reduce that number to 5 or 10.
Great, thank you. For United, the question is, looking at cable management, big part of where, what we do at Armstrong too is, how do you isolate issues with multiple cables in a bundle? And how do you get a baseline for that bundle and then isolate issues within that bundle?
Certainly. A lot of the way that we isolate this is thanks to some of our algorithms, which are currently cannot talk too much on a public setting. However, one of the ways we always are able to maintain this is by reading the electromagnetic field around the electrical wiring. So we are able to notice differences on there. And because we know the baselines already that's supposed to go through there, where our algorithms are able to run it and be able to tell you, what the problem is and isolate which wire within that bundle is causing the problem.
So how much training do you need to get your baseline to start doing the diagnostics?
Certainly. We've been working with Department of Defense, gathering some historical data to help train a lot of our system. So far, we have reached around the 85% accuracy rate on the amperage. We do false positive, making sure that we are on track. We are expecting that by the time that we launch, we have sufficient data to be able to have our accuracy around the 90 percentile. But of course, throughout that year of gathering all that information, we'll be able to better improve. Of course, with more data, better accuracy. And that's what we're trying to do and aligning ourselves.
Great, thank you very much. For Airblock, it seems like each system would have to be customized to the user. So can you provide some thoughts on, how much time and effort does it take to customize a setup for each user? This is for Airblock.
Definitely. Thank you so much for that question. Really, right now, we're working specifically with a handful of companies, and we're trying to understand the key use cases of documents and the types of contracts that they would be managing. Really, at scale, there's you'd be able to go into a database and digitize different types of records. So it won't be too customized because the system would be sort of tailored for document management amongst an MRO or an FBO or an OEM, but definitely sort of within these early pilots that we're working with companies right now, that's really what we're exploring. So at least right now, there's customization that's being added, but we hope to be able to make it really easy to just plug into a series of companies. And they'll sort of be like you're one of 3 or 5 different types of companies, and it would just be able to plug and play into the tech stack that they currently have enabled.
Okay, so yeah, it just seems like everybody does a little differently in different forms, different papers. So
yeah,
be customized for each. Thank you very much.
Sure.
For AvaMek, what type of licensing do the pilots have to have for your vehicles?
They are in SLA, what is Sport Light Aircraft, a special category. So basically, in the one-seater, you don't need any type of license. You need only ground school to communicate with the airspace, and a good training for ourselves to know how you can fly in a safe landing, And these required an instructor certified by the FAA, and he give approval on your logbook, and that is an endorsement that is valid for 1 year. And it's very simple to fly because you have no pedals, you have basically no torque, and you can fly with a single hands. And
right. So flying it is pretty easy. What about maintenance? I mean, if you
it's pretty much zero. Yesterday I was making notes, about that event, and then any subsystem you can replace in 10 minutes. Main blades and rockets you can replace in 10 minutes. The entire fuel line is a kit made by Swagelok, but the very professional, you probably know. And even the skids, in 10 minutes you change anything. I mean, if you go to the field, you just need a screwdriver and a small set of tools, and you're okay.
Great. Thank you very much. Appreciate it.
You're welcome.
All right, and thank you, Dave. You are. We'll hopefully we'll have enough time to come back to you, but I need to move to the next person. Peter Shannon, you're next.
Okay, well, thank you very much, guys. And we've already gone through a lot of great questions here, and so I will try and be additive to those. So first one for Moonware, what other companies have attempted this type of a concept before, and what obstacles did they run into?
Right. So regarding the autonomous vehicle space, there is one main company called Taxibot that basically spun out of the Israeli aerospace industries that has attempted to do this. Currently, their system is not autonomous. So what they've done is taken basically a pushback truck from TLD and put a lidar on top of it and given it a semi-autonomous capability. And it still requires a pilot input from the actual cockpit. But the problem with this is that they were focused on a very specific test case, which was that of towing their fighter jets between the hangar, for maintenance purposes. And they weren't thinking about the global coordination efforts required to integrate with all of basically the ground support equipment for an airport. So when you're considering airport optimization at scale, they haven't really factored that in. And then there's two other startups, one called AeroVec, and another one called Zico or Zing Robotics. So they're focusing on the baggage vehicles, but then again, they're not using a ground up architecture to actually design systems for autonomy. They're doing very similar to what TaxiBot did, which is basically retrofitting existing vehicles. We're focusing on the autonomous pushback because we recognize that down the line, the most value added from an autonomy standpoint to the airlines themselves is that of accidents, mitigating accidents, where about 40% of them happen as a result of the pushback process, but also minimizing the taxiing fuel costs. So eventually expanding into taxiing aircraft from the gates to the runway. And obviously that would be done with a pushback vehicle, not any other thing.
Okay, so you'll start with pushback and automating that. Have you come across any expected resistance from either pilots or from unions of the ground workers?
In all the conversations that we've had with airlines, which is interesting, in the US, there's been more interest in the software. In Europe, where airlines are more digitized, there's been more interest in pushback and the autonomous systems themselves. And basically the reason for this, the need has arisen mainly because of two things. Airport flight volumes, throughput has been increasing over the years. And second, there's been no additional real estate available, so no room to build more taxiways and runways. So they're looking into how to basically improve efficiencies on the ground. And so that's where automation has come into the picture, where, from an airline standpoint and a union standpoint, when you're able to create more flights, so you can increase flight throughput at the airport, you're enabling obviously more opportunity to deploy staff to the ticketing and to, let's say, the cabin. And ultimately, it's those sectors in your staffing or employment that return more money to the unions than, let's say, ramp agents themselves. That, coupled with the natural attrition that airlines face, has not really been an obstacle for us.
Is the bottleneck for throughput at airports really around ground handling, or is it elsewhere in the airport system?
So when we address delays, we're not factoring in airspace delays or weather delays. We're specifically considering carrier-induced delays. And we found a significant portion of that to be in the actual coordination, dispatching, and scheduling of the vehicles. And so what will often happen is that when you have, obviously your schedules are going to be dynamic, let's say when aircraft arrive early or far ahead of time, teams need to be redistributed on the spot. And so for, let's say, low-cost carriers such as Southwest Airlines or JetBlue, which are trying to save every minute that they can, right, where their aircraft spend anywhere between 35 to 45 minutes at the gate, any extra 5 or 10 minutes that, let's say, a fuel truck or a food truck or a potable water truck, for that matter, doesn't make it to service the aircraft, is money that airlines lose. So we understand that sort of optimization or coordination process is extremely valuable.
Okay, thanks. For United, one quick question. I don't know if this was asked already, but do you retrofit into existing aircraft or only design into new aircraft?
Thank you. Yes, we retrofit into existing aircraft, and we also are able to continue to grow with the aircraft. Even there's our carbon fiber frame, we're able to work with them as well.
And when you look at the regulators, such as the FAA, how do you see them as either an opportunity and a vehicle for you to get into market, or otherwise?
Excellent question. Yes, a lot of our efforts is in education and the importance of moving away from metal clamps, which have caused a lot of trouble. Our co-founder, Darren, is actually a committee member for 3 of the committees of SA International, who helps determine a lot of these standards. So our work is to continue working with the FAA for safety and regulations, as well as SAE, to be able to finally shift from metal clamps into a thermoplastic clamp that are far much more superior in performance as well as safe.
Okay, thank you. For Lithium FireGuard, what type of training would be required in order for this device to be, employed, for instance, in the commercial air travel scenario or in other scenarios that you view as your target market? What type of training, would the people on board that aircraft need to have?
Sure. There's no specific training, let's say, required. A lot of the airlines and business jets do like to have their own type of training for their crews. So we do provide a training placard that comes with the Lithium FireGuard solution, as well as a video that comes in a USB key that shows them the various steps that they would need to take during a lithium, fire, a thermal runaway event for sure. So again, not required by, let's say, the FAA per se, but it is typically, and again, airlines or flight departments would like to have some type of formal training that they would implement.
Okay, and I'm just curious, how hot are those fires? What type of temperatures are we talking about that this person would be approaching and then trying to put this box over? How hot is that getting?
Sure. The lithium batteries in a phone or a laptop can typically get up to about 1,200 degrees. Now, when it initially begins and starts smoking, it's not going to be at that degree. But once it's in our box and contained, it can get up to that temperature as it starts to progress. So with a lithium-ion battery runaway, it typically goes through this various cells, right, and it progresses. But at its peak, when it actually starts to ignite and flame, it can be up to 1,200 degrees.
Okay, thanks. That's pretty hot.
Yeah, of course.
I mean, if it was me, as the battery starts to run away, I would start to run away.
For sure, and that's the instinct. But and a lot of solutions out there, unfortunately, the firefighter has to handle the device. Actually. Yeah. Unfortunately, because of the situation they're in a cabin, we give them a hands-free option where they actually can just put our device over, scoop up the device. It protects them, and then they seal it, and the actual device goes through the runaway event in the sealed containment unit.
Okay. All right. Thank you.
All right, and thank you, Peter. We need to move to our next judge, Nancy Mendoza. Do you have any questions?
Just a few, and thank you, everyone. Awesome and impressive presentations. First question's for Moonware. Since you mentioned ATD2, I'm guessing you're also aware of our high-density vertiport effort, and if you saw their ConOps and for automated vertiports and your thoughts on where you would fit into that.
Thank you. So currently we've been working with two OEMs in the vertiport Skyport space. One has been Ferrovial Aeropuertos, and the other one has been another big company based out of Europe. And so we fit more in the operations intersection, in which most of these upcoming eVTOL OEMs are planning on developing aerospace systems or cloud-based airspace management systems to coordinate basically the flight scheduling and also routing of the aircraft themselves, and that's going to be integrated into the Skyport architecture. Our vehicles would be integrated into that, in which we're building essentially a ground vehicle dispatcher and scheduler that that ingests data coming in from the real-time flight scheduling, whether that happens at airports or vertiports, essentially. So we understand that those two domains are sort of they work in parallel in that regards. And specifically regarding NASA Ames, we've also spoken with Robert Morris at the Intelligent Systems Division that has been working closely with SFO, and we're also in conversations with them regarding efforts in this front.
Okay, thank you. My next question is for Airblock Technologies. We're seeing a lot of work on model-based systems engineering on the front end. Or will there be any touch points between your product and the design of supply chains using MBSE?
Sure, could you just repeat the question one more time? A little technical.
So we're seeing a lot of front end work using model-based systems engineering and planning out supply chain models and other engineering models, and didn't know if there was any touch points between what you're looking at and an MBSE of a supply chain model.
Definitely. That's actually something that we're exploring, again, with the MROs, OEMs, and FPOs that we're speaking to. A lot of times, and one of the judges had mentioned this previously, but a lot of companies are sort of creating their own supply chain networks in various different ways, and that leads to a lot of combustion inefficiencies and problems. So what we're trying to be able to do is create a foundational system that could plug into any system, no matter where you are, or any company supply chain network. So that's really where we're trying to build this foundational layer that doesn't exist. And help to really digitize a lot of these processes. Because, you're right, there's a lot of, different systems that are out there, and we want to sort of bring it all within one network, but then decentralize the data so you'd be able to manage and own your own assets and components and be able to track those and provide visibility. So within your company or also amongst your supply chain partners, no matter where you are and from any device.
Okay, thank you very much. My next question is for AvaMek. Can you talk about if you have any plans for airworthiness certification, or do you anticipate remaining with an experimental cert?
Hi, Nancy. Thanks. Yes, we are working with the FAA since the beginning. Okay, we have the quality management system is very, like Boeing or any other manufacturer responsible, I would say. And yes, the request of them was like, we have to fly like 5 hours off of the urban, and then we move to airworthiness certificate. It's achievable. It's very, it's a normal way to launch any type of aircraft.
Okay, so you're planning on getting an airworthiness cert for commercial operations?
Yes.
Okay, thank you. My next question is for Cityzenith. Are you working with any metropolitan planning organizations to model any cities for their metropolitan transportation plans?
We recently started a number of pilot projects working with the 2030 District Group out of New York, which organizes commercial building owners in the major American cities to reduce carbon emissions by 2030. So we started with cities originally, working with San Francisco, Barcelona, London, Singapore, many in the early days. And we ended up focusing on the commercial sector in those cities, which would be real estate developers, ports, energy companies, utilities, etc. So recently, yes, now that our technology is matured, we launched a program called Clean Cities, Clean Future to donate digital twin technology to cities. And the first two that we've lined up in the US are New York City and Pittsburgh, and hopefully San Francisco will be next. So this is just happening as we speak, and we're very excited about it.
Congratulations, it sounds interesting. And I missed, we did an SBI, we had just had an SBIR for smart, serious gaming engines. So looking forward to that. My next one for Stratadyne. Can you talk about your certifications with the FAA? If under what certifications you have for your operations with the balloon?
Gotcha. So with the FAA, we are in a relatively unregulated space. We do notify air traffic control before we launch, and we do put a radar reflector on our balloons. Our certifications do exist with the FCC. We have a CubeSat experiment, CubeSat license with the FCC to control and transmit data from the stratosphere to the ground in real time.
Okay, and thank you, and yeah, thank you everyone. Really great and definitely inspirational. Robin, that wraps up my questions.
Thank you so much, Nancy. And our final judge is Aaron Greenwald. Aaron, any questions?
Aaron, you may be muted.
We may have a technical glitch. He may have dropped.
Okay. Robin, do we want to donate? I know that Dave and Harry both had a couple questions they were looking to have go backs for. Do we have time to donate to them?
We're actually a little over schedule, but I'll
Okay.
take one question from each.
Okay.
Harry?
Yeah, for Moonware, I understood how you were doing compliant. I'm sorry, wrong company, Airblock. I understood how you were using your software for compliance, but I didn't get really a feel for the flexibility for searching and finding specific information. Can you comment on that?
Yes, absolutely. This is an area that I get really passionate about. So the benefit of digitizing your documents, especially from a serverless way, you'd be able to, from any device, no matter where you are in your company or really outside of the company, you'd be able to then search through a database of all of your records that are traced, that are being tracked in real time. You'd be able to share that data with other companies. So a lot of times right now, and I was actually just talking to my co-founder about this before this event this morning, companies might just have boxes of documents that's just stored and filed, and it's not actionable, it's not traceable, it's not verifiable. So what we're working with companies on is a completely new way. So instead of it being sort of that paper-based document supply chain, it's now fully searchable, fully traceable, and you'd be able to work amongst your companies to share data, share contracts without any lag, any delays. There's even inefficiencies and delays where you might have a document and you might need a certain number, but because you don't have that file on hand, you have to go and search for it. So having it all within one centralized repository that is decentralized, that's really the mission and vision of a really evolution of supply chain, whether that's compliance or for your company.
Can you add permissions to various documents?
Absolutely. We'd be able to permission it and store. So whether that's you want to share it with a certain company and that's a time-based permission, or if that's generally for the life cycle of a contract, you'd be able to permission that however you choose and however you please for the companies that you're working with.
All right. Thank you, Harry. Dave Vorsak, one question, please.
Yeah, this is for TargetArm. You talked about the need for aerodynamics and that. So, Kurt is wind tunnel. I do actual flight testing on real aircrafts. So, what type of testing in the aircraft and looking at the flow downstream, the approach to the main capture device?
Yeah.
Do you have any of that type of data yet, or still looking for that?
No, we do not. That's one of the major things we need. So we need to know where the turbulent layer ends, where the clean air starts, and what type of approach vector we would want to take to come in and be recovered into the Tular device.
Okay, yeah. Seems very complicated in small vehicles approaching the larger one.
It definitely is a complicated problem, but we've seen it be done in air refueling. So it is within the realm of the capabilities we have today.
Okay, thank you.
All right, thank you very much. Judges, Max, back to you.
Yes, thank you, everybody. I thought the presentations were great, and thanks to the judges, a lot of really good in-depth Q&A. We are going to, I'm going to leave now with the judges to do the behind-the-scenes work, and in the meantime, I'm going to hand off to our co-host, Jen Consalvo, who runs an organization called Established and a competition called Startup of the Year, and she's been a longtime partner and friend of NASA iTech, and she will continue the programming here and introduce our two speakers.
All right. Thank you, Max. Hello, everyone. I'm Jen Consalvo, the co-founder and co-CEO of Established, as Max mentioned, and managing partner at Established Ventures. And I have the great privilege of working with the NASA iTech team as a coach and a strategist. I hope all of you really enjoyed the presentations and insightful questions from our judges. Our innovators have certainly been working very hard on these over the past few weeks. So now I'm happy to introduce our first speaker today, Marty Wasak. Marty is a Deputy Project Manager of the Convergent Aeronautics Solutions, or CAS project, in NASA's Transformative Aeronautics Concepts Program, currently serving a temporary assignment in the NASA Office of the Chief Technologist. CAS is the seedling project for NASA Aeronautics and consists of a diversified portfolio of activities pursuing innovative concepts and focused on system-level benefits with the potential to significantly outperform current solutions. Prior to that, he was the Langley Deputy Center Chief Technologist, responsible for supporting the center's efforts concerning technology policy, coordinating and tracking technology investments, and fostering and sustaining an innovative NASA culture. He managed the center's IRAD and Center Innovation Fund investments and served as an advisor for numerous initiatives associated with early-stage technology. He also co-led an agency-wide team to identify and recommend ways to mitigate barriers to innovation at NASA. Earlier in his career, Marty was involved in research and development associated with the dynamics and control of advanced aeroelastic vehicles, including micro-aerial vehicles, supersonic transports, and highly agile aircraft. Marty received his bachelor's and master's degrees from the School of Aeronautics and Astronautics at Purdue University and pursued postgrad studies at Purdue until he joined NASA in 1987. His major area of study was dynamics and control with focus on applications involving structural dynamics and unsteady aerodynamics. He is an associate fellow of the American Institute of Aeronautics and Astronautics and has been awarded NASA's Exceptional Service and Outstanding Leadership Medals. Thank you for being here today and welcome, Marty.
Sorry, I was muted. Thanks very much. I didn't think you'd read the whole bio. I was just asked to provide a bio. So thanks very much for those kind words. And I know we're running a little over, so I'm going to cut to the chase on a few of the charts I have here, so we have time for our other speaker. But what I did want to do is make some connections between the startups and venture capital kind of activities that are going on, in the commercial sector, and our attempts to learn from take the lessons learned from those efforts, as well as adapt them for use in a government laboratory. So I know there's a number of initiatives like this going on across the government, but CAS, Convergent Aeronautics Solutions, is NASA Aeronautics' approach to doing that in the context of a seedling project to really look at early stage concepts that could be advanced. So the main focus for anything, any of the research activities in aeronautics, though, are to be aligned with the strategy and the strategic plans that aeronautics has for the future, and that involves supporting the growth and sustainment of global aviation, addressing the challenges of climate and congestion, noise, and other things that impact the community, and also because those are big challenges and difficult to address, and have resisted solution using our more traditional aerospace technologies and disciplines. We're also looking to be more transformative and having the investments that we're making in the government labs have a larger impact and direct value to the society and the industry that supports it. So if you go on to the next chart. So one of the things that we all recognize is that there's a number of global trends that are really strongly challenging and affecting the way we go about doing R&D, particularly within the government. So some of that is just the accelerating growth and generation of new knowledge and the democratization of that information and knowledge through things like the internet and the other IT technologies that allow it to spread so quickly and be adopted very broadly, and also lowering the barriers to entry into developing new ideas. And since NASA's early days, NASA was generally pushing it was a trailblazer and a pathfinder for new technologies, because they really challenged the challenging missions NASA has were difficult to accomplish or impossible to accomplish without developing new technologies. In the two waves of innovation since the 50s and 60s, when aviation was the post-war period in which innovation was running rampant in aviation, and it was driving a lot of these technology developments, NASA now is in a situation where it's really relying on the technologies that are being developed in other industries and adapting from them for aerospace. Could you go on to the next chart? And so in addition to that, the amount of investment that is in the private sector compared to what is being spent within the government has really flipped over the last 30 years. It used to be that most of the R&D funded in the United States was government funded. Now it's a relatively small fraction of the overall R&D investment in the United States. And similarly, back when I first joined NASA, most of the R&D in the world was done in the United States. and now less than half of it is done. Though it's still a substantial fraction, it's still eroded compared to what's going on elsewhere in the world. So these trends are obviously influencing the ability of NASA to accomplish its missions. Next chart. And so what's happening is we're really looking at the benefits of adopting technologies that are being developed outside of the traditional aerospace disciplines like aerodynamic structures, propulsion, and so forth, and applying things like automation, big data, machine intelligence, and AI, additive manufacturing. All of those types of things are being quantum computing. Those are being developed outside of aerospace and with primary applications elsewhere. But there are value for many of those technologies within aviation and aerospace. And so we call those convergent technologies, those technologies that can be blended with the traditional aerospace disciplines to address the big challenges I talked about earlier. And so, and also many of the markets that the speakers today are addressing. And so obviously there's a lot of connections between what NASA's needs to be able to do in aerospace and aviation and what happens in the startup world. So we're trying to use the Convergent Aeronautics Solutions project as essentially a laboratory for adopting those types of startup mentality, entrepreneurial skills, and methods, and apply them in a government laboratory environment. Next chart. So the way NASA Aeronautics is structured, it has three main we call mission programs focused on vehicles, the aerospace systems in which those vehicles operate, and the demonstration of those technologies to encourage the transition and adoption of those technologies in the private sector and to support industry and society. We have a fourth program, which is called Transformative Aeronautics Concepts Program, which is where CAS resides. And it is intended to be more forward-looking beyond the next decade or so, and to look at these alternative approaches to solving the technical challenges that we're facing. And so I'm going to talk a little bit, obviously I've been most familiar with Convergent Aeronautics Solutions as a project. And so I'm going to talk a little bit about what we're trying to accomplish within that project. And I think there's a lot of opportunities, and we've been trying to develop better connections and relationships with the venture capital and startup world to couple and partner in these convergent areas. Next chart. So the aeronautics has taken a big step forward in trying to address many of the challenges and respond to the challenge, the mega trends, the global trends that I described earlier, and with the growth of emerging markets like urban air mobility, drone package delivery, use of advanced sensor technologies and communication technologies and so forth, as well as the supporting industries that are popping up, we're able to develop new capabilities beyond the outside of the traditional disciplines and that transcend them to some degree. And so CAS is really a laboratory for trying to address those, but also demonstrate the opportunity to invest in them and scale them to larger programs that are projects that could fit into those mission programs I described earlier. Next chart. So from that perspective, CAS is really trying to foster transformative thinking. So we're really on the lookout for transformative ideas, some of those which we saw today, and make partnerships and leverage the knowledge associated with those applications to help advance the strategic objectives that we talked about earlier. And then at the same time, also experiment with some things like VC, venture capital type of approaches to managing portfolios, making investments, taking risks, informed risks for the potential of high payoff, and also the role of working in multidisciplinary, cutting across disciplines to innovate at the boundary between disciplines. Next chart. And at the same time, we're looking to develop this workforce within NASA and our collaborators and partners to transform their thinking to operate in that different kind of transformational and convergent kind of approach. And so by developing the capabilities for particularly early career employees to give them an opportunity to be exposed to new ways of thinking, collaborate and network more broadly and more broadly and at a higher level of focus with their peers in other disciplines across the agency, and also to have the opportunity to go through the life cycle of a program or a project much quicker than they would in a normal mission project, which oftentimes take 5, 6, 10 years. Our activities are much shorter in duration. But they're also not focused on developing the technology as much as demonstrating that the concepts, these transformative concepts, actually have potential, are potentially feasible, and could be adopted and developed within our more mature and longer term mission projects. So in this way, it's very much like a startup. Identify the value of the idea and the potential for it to be successful. Next chart. And the primary goal for all of this within all these activities within CAS are to really have transformative impact. Now, it's important to recognize that CAS is not going to, with a short-term investment of a couple of years, exploring the feasibility of very high impact, long-term, transformative type of thinking and methods, that those impacts are not going to be immediately evident. It's going to take time to develop them and demonstrate them, especially for aviation, in which safety and economic viability are critical elements. So part of the demonstrating the transformative impact is that not only is the solutions and the concepts that are being developed technically feasible, but they're also viable within a business context, as you guys have talked about earlier today, as well as meet a really important and unmet need or opportunity within the marketplace to support the end user, customer, society at large. Next chart. Keep going. I think this one has got animations in it. So the way we, and this is really, I emphasize that this is kind of a countercultural experiment for NASA aeronautics, because it's not the traditional way in which research is planned and executed within NASA aeronautics. And so some of the challenges are to build mindset shifts within the teams that are working and within the broader workforce to be able to develop these transformative concepts. Can you hit the advance one more time? I think it'll bring one more time, maybe. Oh, go back. Okay, so the way CAS is, one of the ways that CAS is doing this, and there's a variety of other approaches that we're pursuing, is to identify certain key attributes which are different than what most NASA projects pursue. For one, we're looking for transformative impact, not next logical step, not sustaining innovations, but really breakthrough, disruptive, transformative solutions. And that obviously, for the bigger benefit, also entails taking on greater technical risk. And NASA is kind of known to be a fairly risk-averse organization, and so we're trying to break that mindset by demonstrating that by pursuing big goals, and we taking reasonable risk within the context of doing that we can be successful. Also, as I mentioned, adopting convergent technologies. the concepts coming into CAS have to have some element and component of convergence, bringing technologies that are developed outside of aerospace and applying them in an aerospace environment, working with folks that have backgrounds that are outside of aerospace and taking advantage of their alternative perspectives in helping solve some of these technical challenges, engaging with organizations like smart cities groups or folks that are working in advanced manufacturing technologies and so forth, so that they bring a different perspective to the solutions. All of this has to be done in a targeted way that's aligned with NASA's overall strategic direction and goals, but also looking to disrupt the existing portfolio to identify opportunities that have potential to be more significant and impactful than what is currently being invested in. And then, as I mentioned also earlier, focusing on feasibility before making the investment in new technology development so that the return on that investment is more likely to be at a high level. And then to execute this in a more rapid, agile way, which is also not traditionally the government's strong suit in doing things quickly. So this is a way, by having folks respond to these attributes within their concept development and their project planning, we're able to instill some perspectives on these transformative thinking. Next chart. So as I mentioned, it's not kind of cultural in many ways. So CAS is at the same time trying to be revolutionary, but also relevant, trying to emphasize the value of convergent technologies, but also maintain our core capabilities, retain and deepen our discipline expert, but at the same time focus on system level benefits. So these are many ways of paradoxes that we're trying to address within CAS and facing them straight head on, and recognizing that there are challenges to do that, and that we're likely ourselves going to find that some methods work better than others, some approaches, some processes, and so forth. And we're a learning organization in the sense that we're continually adapting and modifying how we're going about doing this. In fact, CAS is right now in a reformulation phase in which we're putting much greater focus on the viability and desirability aspects of these concepts so that they really have the potential to be transformative. Next chart. So it's a continuing journey. We're in the process of becoming, and it's not a simple task to do so. And so one of the objectives is to increase the understanding and awareness of CAS, and doing talks like I am today here with you folks, and also encouraging the collaborations and building these ties and building networks between NASA and the external community in this area. These areas of transformative convergent solutions is really important. So participating in something like iTech is of credible value to us. So I will look forward to hearing from some of you if you're interested in being more involved in NASA's research, particularly within convergent aeronautics solutions. So thanks very much.
Wonderful. Thank you so much for joining us today, Marty. We appreciate it.
It is my pleasure. Thanks.
All right. For those of you just joining us, we heard from 10 amazing companies today, and we have one more guest speaker who will present to you as our judges decide who our Ignite the Night winner will be. Our guest speaker, PK, serves as the director of NASA Aeronautics Research Institute, or NARI. In that capacity, he is responsible for exploring new trends, collaborations, and partnership needs related to aviation enterprise. He also serves as NASA's senior technologist for air transportation systems and principal investigator for the unmanned aircraft systems traffic management, or UTM project. Welcome, PK. Thank you for being here today.
Well, thank you very much for having me here. I'm really grateful for all the wonderful things that I saw a little while ago, and it's great to follow up after Marty's nice talk because it dovetails with what he's already shared. So I'm looking forward to this conversation with you all. Hopefully you can see my screen. Are you able to see my screen in the presentation?
Hold on, PK. I'm sharing from my side.
Oh, okay. Oh, you are. Okay. So should I stop?
Yes, please.
Okay, perfect. That's awesome. Thank you, Robin. I very much appreciate that. Always great to have that help. All right, so I will be talking about cultivating spirit of innovation, somewhat of a personal journey that I happened to turn around. So this idea that innovation is something mythical is something that I would like to kind of break down and show that the innovation is very much a process and phenomena and spirit that you can actually cultivate yourself. So I will talk about the overview of the innovation, the individual characteristics that you can look for and build on, as well as how do you lead innovative organization and innovation, whether it's product or service. And then what are the key innovative things that we need to see in aeronautics, kind of unfinished business, and then summarize towards the end. Next slide, please. Thank you, Robin. So the whole idea of innovation is that it's a fresh idea. There are many definitions, but this is my definition. Fresh idea with clear execution that produces tangible, positive improvement. The key here is the positive improvement and an idea that's executable. And you can have innovation of knowledge, a product, a service, a business model, a process. You can innovate along any place. So it doesn't have to be only technology. It can be in procurement. It can be in processes or different business models, the way it's executed, and so on and so forth. So we'll talk about some examples of that as we go along. Next slide, please. Let's look at innovation types. And this is important because every organization needs all these types. And sometimes one outdoes the other type of innovation, but it's not very common that you have disruptive innovation on every day. So you typically tend to do incremental innovation all along. So these are like Windows 9, Windows 10 upgrades and air traffic management system related upgrades or aircraft related upgrades. They keep on incrementally improving the performance of some characteristics or multiple characteristics, and they sustain over a period of time. Every now and then you will see a disruptive idea comes along and a paradigm is shifted. And that example of that is unmanned traffic management. So from air traffic management, we were able to change the paradigm from clearance-based execution where pilot has to get approval from controller to a place where clearances are not required, but it's management by permission, from management by permission to management by exception. So you get to know what not to do, and then you can figure out how to basically navigate around that. So that's the disruption that occurred, and paradigm got shifted from management by permission to management by exception. The third type is the new markets. You completely open in new markets. So quieter aircraft now, because aircraft is quieter and smaller, you can actually end up going to places you were not able to reach before. And integrative innovation, that's sort of a smartphone that couples a bunch of ideas and technologies together, and you have a basically capability that you didn't have before. Next slide, please. My main point is that everyone can be innovative, and that's sort of whether you're a procurement person, whether you're mission support, whether you're a technologist, whether you're management, execution, human resources. Any one of us can be innovative at different levels, and those things that I shared with you in the last slide. Impact is what defines the importance of innovation. I mean, I'm sure all of us actually do something different than we did yesterday, and we improve on it. And that's sort of a very simplistic example of innovation, but the impact of that innovation will basically define how important that innovation is. However, we had to keep in mind that we can't judge a fish by its ability to climb a tree. Different type of skills. So if I'm a technologist, I can't necessarily be expected to innovate in the law field, or the lawyers can be expected to innovate in some other field. So you had to really judge the importance of that innovation based on that particular field and the ability that is required for that. That's the main point. Everybody can be innovative. The importance is based on the impact, and that only is defined by the abilities that are needed to achieve that. Next slide, please. So as an innovator, what do you expect? You can expect a lot of ambiguity and a lot of uncertainty. You have to make decisions and choices and trade-offs many, many times, and very uncertain. You're not going to know for sure that is a direction, that is the right direction for the most of the times. You can focus on big missions, and I like to say that the innovation spirit requires a big idea, a big mission, something that inspires you. But it's very difficult to achieve that big mission and think about it every day, even though you may be obsessed about big mission. You have to basically put it down into chunks. So compartmentalize that big mission that you are after, going to moon, going to Mars, or however it is. You can compartmentalize those and then create micro missions. Other way the Silicon Valley thinks about it is minimum viable product, and you create minimum viable products and then figure out that those products are going to be important for someone, add some value, and keep on improving and adding those incrementally after that. You certainly will offer a lot of technical contributions as if you are in the aeronautics, obviously as I am. So most of my contributions are related to technology, but you could be in the law, you could be in the mission support, and you could still offer those. One of the challenging things I find is convincing other people that this idea or this kind of innovative spirit is worth pushing forward. A lot of times it takes basically effort to convince people, particularly if you're thinking in a different way and trying to push towards a different paradigm. Convincing others could be hard. So you really need to have a communication approach. You need to figure out how to actually explain why what you're going to do, what you're suggesting is important, and how it would impact the society at large or the community of interest at large. What value will it add? Most organizations have resource constraints, and NASA is not unique to that. Any organization, you name it, they will have resource constraints. So management is constantly trying to figure out how to balance the priorities and portfolio. So it can be frustrating sometimes that something that's ambiguous, something that's uncertain may not get as much attention right away. But the main point there is that you could get resistance in the beginning, you could get rejection, you could get kind of tacit response, sometimes ridicule in some areas. You got to accept all of that. And if you deeply care about that mission and the idea that you're really after, then don't give up and, keep trying different ways in a nice way, in a professional manner, obviously, but keep trying those different ways and expect all these things. And sometimes those things make you stronger. Sometimes the resistance makes you stronger. It tests your resolve, it tests your ideas. Critics also test your resolve and your ideas and the importance of those and the value. And it's really critical to ensure that you are able to articulate the value, who gets the value and the economics behind it. And I'll give you an example. Unmanned aircraft traffic management, I think one of the reasons why it got adopted globally, and particularly FAA, is the economic side of it, because the conventional air navigation service providers have to make all the investment on the radars and communication, navigation, surveillance, and air traffic management software and all. In this case, because we separated the idea with service-oriented architecture and such, the air navigation service providers still could be in charge, but they didn't really have to invest in everything. And that was a powerful benefit that got accrued So you are still able to reflect on the authorities you have and approval processes, but without having to invest a ton of money. And that's where the significant economic benefit was accrued. And that's when that idea got accepted, even though that's not what I was thinking about before. I was thinking about how do I accommodate millions of drones in the sky. That was the idea that I was obsessed with, the big mission like that. But then really what got it accepted is the economic side of it. Next slide, please. So as an innovator, a lot of times, this is a classic saying in 1918 by Nicholas Klein, first, a lot of people will ignore you. They will ridicule you. Sometimes they will attack you. And they will want to burn you, and then they will build monuments around you. So the choices of the words here you can ignore, but you can ignore basically type of attitude. You can expect some type of ridicule or just basically not paying attention to it. But then, if you are able to convince other people through your persistence and through your dedication, then it will get you basically to the end result you want. I mean, one of the really sayings that I like is, dream is not what you see in the sleep, but dream is what doesn't let you sleep. So you have to kind of obsess with that idea that you have. You're focused on that so much that you're really thinking about it all the time in a way that, how do I actually get that? How do I make that happen? And that takes significant commitment and an obsession about it without having to disturb your family life and all of that, obviously, without having to disturb personal relations and professional relations. But you got to be committed. And main point there is that commitment, and you have to expect all these things that will be not so kind to you all along. Next slide. But at the same time, you will see a lot of allies. They will be happy to help you. There will be people who will be willing to help you and go out of the way unexpectedly. You will have lots of friends as well. Leading innovation. So as a leader, if you're basically a company, you form a company and then you start to grow into the product and you become a leader and you're trying to cultivate interest from other folks and make sure that the others are equally, basically excited about it. You had to do two things, and this is the message at the last bullet there, is that you had to have balance of strategy. So top-down, excited kind of product focus or service focus or some kind of value focus, and a culture that allows people to bring their ideas, experiment them, and encourage them, even though they may be wrong. You may know already that certain idea is incorrect and wrong, but you got to give some people some latitude and flexibility to experiment them, because they have to learn from them for themselves for the most part, unless it's a really type 1 and type 2 type of decision making. What Bezos says is type 1 decision making is irreversible. So you have to make those decisions very carefully, and type 2 decisions are reversible, and you can actually experiment with them because you can reverse back. So you had to balance the strategy and a culture very carefully, and you must have both to have this innovation mindset and organization to be successful. You have to make a lot of trade-offs, and you cultivate these relationships and innovative spirits. At the same time, you have to be able to explain if you make a trade-off that was not necessarily other people liked. So being able to explain that is going to be very important. So again, it goes back to the original point I made in the last slide, that it has to have some value to the enterprise. And these strategies will be evolved over a period of time, because most of the times you have a hypothesis in your mind and you build towards that, and sometimes you're correct, sometimes you're not, and then you can move on. Next slide, please, and I'm almost finished here. Where do we need innovation? We need innovation in aeronautics, in zero emission, getting to that ultra low zero emission, increasingly available aviation, every zip code, every place. We need to have some kind of aviation touching people's lives, whether it's small drones delivering things or inspection, or larger aircraft going across country areas, faster, supersonic, hypersonic, across the globe. Affordability is critical. It must be, so that everybody in the society can benefit from. It's got to be continuously self-aware if you are looking at large scale and large densities and complexities, so that the system has to balance the performance of safety and scale, efficiency, and the throughput. All of those need to be simultaneously accomplished. And we had to enable autonomous operations because that's when you can increase the on-demand, reduce the basically dependence on this complex scheduling. I'll give you just one example. The current aircraft, long-range aircraft, have stage length of 16, 18 hours, but the fatigue rules say you can only carry, pilots can only work for 8 to 10 hours. That means you have to carry multiple crews. And if you're going from San Francisco to Japan and turn around in 2 hours, you have to carry another set of crews to basically accommodate for that because there's a duty rest cycle issues. And that's hugely expensive. So how can you turn this around into an autonomous operation or increasingly autonomous operation where people's livelihood is not going to be as disturbed? While we don't promote that we should eliminate people from the system, but at least it should maintain a good lifestyle. So instead of 3 crews and a couple of them are sleeping, you want to try to see if you can build systems that are increasingly autonomous that will balance the need for better lifestyle as well as the operational efficiency and safety. Next slide, please. This is my last slide. So my main point is maintain a worthy focus on the mission. You get excited about it, and other people will also. Innovation is almost a lifestyle, and but don't burn your reputation. You will be basically suffering at times. You will be praised at times. Things will be up and down many times. So you can just accept that and be vulnerable to failure, in many cases ridicule, and that's okay too. But you will create allies, and you should create allies and learn from your critics and improve on it. And remember always, it's not about us personal business. It's really about that mission. The mission should be such that everybody will follow along, and it shouldn't be about someone who is driving that innovation. It should be about that mission. Learn from others as well as your own mistakes. Obviously, everybody knows that, but it's very difficult to do because a lot of us don't like to admit mistakes, and it's good to actually be self-reflective about that and help others succeed. Be a mentor, and that's when you also grow. You can start small, you grow, you evolve, stay agile, and then help other people to succeed. And then that will be a very fruitful journey for you, as it has been for me, even though there are times I have been very nervous about it and not so sure about it. But overall, it's been really great. So thank you for your time and appreciate all the things you're doing and the spirit that you have towards innovation. So don't give up. Good luck to you, and sort of look forward to seeing progress from you all. I will succeed if not on this particular project or a product or service somewhere else. So, thank you for all the hard work and spirit that you're demonstrating. Thank you for inviting me as well, Maxwell and Robin.
Thank you, PK. It was really great to have you as a speaker. We really appreciate you coming, and Marty too. Great to have 2 NASA thought leaders in aeronautics to kind of describe to the group how we think about innovation, some inspirational words on how to see things through in the face of adversity. Really appreciate that. And we are running over time here, and so I don't want to belabor the point anymore. I want to get straight to the winner, and I would like to invite to the stage United Aircraft Technologies. We chose them as the winner. There was a lot of discussion on the applicability to both aeronautics markets, but also a great opportunity possibly on the space side of the house. There was discussions about just how much of a problem electrical troubleshooting was on the space shuttle, and how much cost and time there was involved in that. And so we thought it was a system that had great potential to save people a lot of a lot of time, a lot of money, and it's one that fits a nicely sized addressable market for something that's in a NASA need that might not necessarily get some attention because it doesn't clamps aren't something you hear about at a lot of in a lot of pitch competitions, but we think these clamps are special. So thank you, Abigail.
Oh, wow. I've been in shock over here. I'm so thankful to both the judges and the amazing people in this group that I'm amazed at what everybody has done and continues to do. My team that helped me create everything, and the support from NASA iTech to make sure we execute. And after all, I want to go towards innovators, veterans, and my co-founder that experienced this pain, and now we're working religiously to fix this in the aerospace system and going after a market that some people think that is a difficult market to go to. So I just want to thank you so much for the opportunity to showcase what we do, and I am eternally thankful for giving me this platform and giving me the opportunity to make that difference, because technology and innovation is here, and there are definitely ways of improving it, and I'm so glad that a lot of people are seeing the same way. So I'm gonna switch to Spanish if I continue going on. So thank you so much. I appreciate it.
All right, thank you, Abigail. And thanks to all of our competitors. You worked very hard, and it was great working with all of you, and we wish you all the most luck going forward. Thank you to everybody tuning in, for joining the program. We appreciate it. And if you have any more interest in NASA iTech, please visit www.nasaitech.org.
I'm excited.